All right, I guess we can start now. It's 17:20. So yeah, thank you for showing up. Thank you for all your time. Thank you for being here. I'm gonna talk with you about load balancing Cloudstack agent connections here. My name is Boris Stoyanov. I'm a software engineering test at Shapeoo. And yeah, I'm gonna do an overview about the feature, what it is, what problem does it fix, and basically I'm gonna show you a little bit of demo on how to use it and that sort of thing. So yeah, a little bit about me. Yeah, I break stuff at Shapeoo. I have more than 10 years in software testing. A couple of disciplines I specialize in. I've joined Shapeoo and Cloudstack in 2016. So speaking of most of the people here, I'm still relatively new to Cloudstack, but yeah. A bit about Shapeoo. I think you guys know who we are, what we do. We have some clients that I'm gonna just skip through. Yeah. Some overview about the software load balancer feature of Cloudstack agents. So what it does, it's basically offers you a software way to replace a regular load balancing instance machine that you would normally use to manage all the connections from the agent to the management servers. It's built on top of both management server and the Cloudstack agent. So the whole logic and the whole piece of software, the changes are basically inside, built in the software. So it comes with Cloudstack. You don't need to install anything more than that just to use it. It supports a few configuration algorithms that you could utilize with your setup. And it has a fallback mechanism that you would find pretty neat. So let's talk about the general setup that you probably use when you have a clustered management environment. So let's say that within your cloud you have 3 management servers and a dozen of hosts, doesn't matter. So what a normal setup would look like is your management servers are connected to the host throughout a load balancer machine. So that's nothing. There's nothing. That's great. There's nothing wrong about that. But if we try to think about it, let's think about a couple of downsides of it. So you have it costs an infrastructure to set it up. I mean, you need to build up a machine for that, dedicated. It comes on a certain cost. It can be open source, but yeah, if you want fully sufficient product, you're probably gonna pay money for it. And of course, it takes skill and time to set it up, to hook it up, and basically to integrate it in your infra. So if we, for example, imagine that you need to set up like firewall rules, or if you use, for example, SSL connection between the secured connection between the management and hosts, it could take time to set it up basically. So within the software that we built, you simply eliminate that single point of failure, and you carry out with a direct connection between the management and the agent. So meaning that the whole load balancing logic is taken out and it's been implemented in both in the management server and the host. So in this simple picture, you have a diagram showing the primary connection between the management and the host, and backup connections to all the managements that you have currently within your environment. So a little bit to sum it up about the feature. It comes built in. You don't need to install anything. You don't need to support anything more than that. It's like easy to use. I'm going to show you in a few seconds in a demo, and of course it's free, open source. Yeah, so as I mentioned, that it's built for Cloudstack agents only, meaning that your KVM hosts and your system VMs are going to use it. You can design the logic that you want to implement. It uses the already provided setting within the global settings. It uses the list that you set for hosts and utilizes that for the algorithms. And it does not require a restart when you do changes, so you can directly go add another host and change the list in the global settings, and you don't have to restart it to make it work. It will simply pick it up and distribute it, propagate it to all the Cloudstack agents. Sorry. So the setting is called indirect agent load balancing algorithm. This setting basically shows you basically set what you're going to use for the logic of the load balancing. So you have three options: static, round robin, and shuffle. So static is pretty much obvious. Whatever you define in that list in the global setting, that would get propagated to all the Cloudstack agents, and they will use, every one of them will use the same list. It's not really balancing anything, but it's sort of the disabled mode of the feature. Shuffle. Shuffle is if you really want to use something random, it will generate a random list on the base of that list that you set in the setting, and it will generate a random list per each host, and it will propagate it to it. And the last option that you have currently is round robin. So that's pretty simple logic to do the balancing between the resources that you have. So for example, if you have, let's say, tree management and a dozen of hosts, so first host will get the order of first and second and third management server. The other will get the second, the third, and the first one, and the next one will get the third, the first, and the second one, and that will repeat until you get all the lists of hosts. Hosts. A couple of words about the fallback mechanism. So you have another setting that is interval, where the agent will look if it is connected to the right host that it's supposed to be. You can set that in seconds, and if you set it to 0, it won't do anything. It will just stay connected to whatever, and if it goes down, it will stay disconnected. So if, for example, if you set it to 30 seconds, and every 30 seconds it will go and check if the host is, if the right host is, if it is connected to the right host, and if not, it will try to connect to the right host. So in the event of failure, for example, if I'm an agent, I'm connected to my primary host. If it goes down, I will move to the next one, and every 30 seconds I would go and check if the primary host is up, management is up, and if yes, I will connect to it. So this setting can be set on a cluster level, and of course can be overwritten in the agent properties if you like, to be specific for a particular host. Of course, making changes for this setting will not propagate any new list for the agents, and yeah, you don't need to restart management server to do so. So yeah, let's have a few slides and just to see basically how this fallback mechanism works. So let's say that the KVM host is connected to management server A and its preferred list is ABC. So in an event of this particular host A is being unavailable for some reason, it will simply switch back to the next management in the list, in the preferred list, and it will stay there. And being there, in every 30 seconds, it will check if management server A is up. And if that comes up, it will eventually move to the primary one. So yeah, let's do a little bit of demo about it. If my computer works, actually. So I'm gonna stop this now because I don't see anything on my screen. Right, give it a little second. So I'm connected through my phone over VPN to our lab in London, so hopefully everything goes okay. I have a pretty simple environment, having 3 hosts and 3 management servers. We can see that they are all up and running. Let's go and see the if I write that wrong, yeah. So we have a setting of static. So basically, by default, it comes with a check interval of 0, which basically means disabled feature, and algorithm of static. So in this case, whatever we have in our host goal setting, it will get propagated to all of the management of the KVM hosts. Sorry. So let's do a little check. Yeah. So this particular host, KVM3, has a list defined. The first one is 130. I hope you can see that, by the way. Can you? Yeah, sorry. And you can see at the end of the line you have like annotation of static. That would make your life easier if you want to know what's going on there. So if we go now and change this to round robin, for example, let me copy that directly. Okay, so that's not required actually. You don't need to restart it. And if we try to see what's happening here, okay. So we have a new list propagated, 134, 130, 133, and round robin. So this means that this agent probably reconnected to 134, or if not, it will do it within 30 seconds. And yeah. Yeah, it did. Okay. So if we try to like reproduce an event of failure now, if we go and shut down management 134, which is this one, if we just go and stop it, we can see that it's currently being disconnected from 134. And it moved to the next one in the list, which is 130. So it it was connected to its primary host. The host went down for some reason, and it jumped to the next one from the list. It's pretty simple. I mean, it's not really a science fiction, it's rocket science, but yeah, it's a simple solution. Let's now put back 134 on. Let's just start it. It's gonna take a couple of, maybe a minute to start. And in the meantime, you can see in the logs probably, if you can read it, that every 30 seconds it will check if the primary connection is up, and eventually when it comes up, it will it will just connect to it. Let me. So that's 134. It's not up yet. It will come up in a second now. And our KVM host will be able to connect to it. So before 4.11, you could have seen when the management server was loading, you could have seen this page loading, but because of we did this keeping all the files in one jar, just one jar, it uses some different libraries, and now you can't see that in the background the management is actually loading, and it just displays that page is unreachable. Yeah? Okay, no, it's not up yet. Yeah, it's coming up. There you go. So our management, it's up. And yeah, I think we just connected to host 134 here on this line. Yeah. So what happened, it got connected to the primary host. So first it was connected to primary host, then we shut down the primary host. It moved to the next one from the list as a fallback mechanism. And it kept on trying to connect to its primary host, and eventually when the primary host went up, it just moved back to it. And I think that's pretty much the feature. So if you have any questions now, you can ask. That's a QR code for a small survey that I've put up on SurveyMonkey, and it's just 4 questions like whether you like the feature, whether you would like to explore it to see what it is like, and if you need that it's mature enough that you can that you would like to use it in your environment. Just a quick feedback for me. If you like, you can just scan it and do the survey. Yeah. So questions, yeah, Andre?
Before this software-based implementation of OpenApp was done, previously you could also define the host variable. Now the question is, if I'm not mistaken, this was only consumed by the system with ownership, right? Because in the agency, if you overwrite the agent file, if you overwrite the IP address of the management server manually, it will stay like that. So all these changes are basically implemented in dynamically populating also CCC the agent of properties file, but if you replace it manually, how does it work?
So the question is if you do some overwrite on the agent side, will it get overwritten in time? Is that the right question? So yes, it gets overwritten if you change the list of management hosts. If you reconnect the agent, it also gets propagated again. And yeah, I think that's the case, is that gets overwritten. If you don't want to override those, you can set the setting to static, and it won't override them at any case. But then you won't be able to use this feature again. Yeah. You still can use it, you still can use the fallback mechanism, but you have to use your own solution to do the agent side of configuration and propagate the right list for you. I'm not 100% sure. So the question is, can you specify multiple management hosts before for that 4.11? I think you're not able to specify that. And if you're gonna run clusters, you need to set up your load balancer within that.
Short final question. Did you actually, doing enough testing? Sure. But did you test, for example, if the agents switch over from one management host to another, is it working fine and gracefully as, for example, if you have a long-running job like Snapshot or something like that?
That's a very good question. So question.
This is why I'm asking, because if you have
Yeah.
agent disconnection, you could actually not reconnect,
Yeah.
test, whatever do because of 5 outstanding actions.
Yeah. So just to repeat it, if what happens if you have a background job running at the agent side and you want to at the same time jump to your primary connection, right?
Or maybe that server out.
Yeah. You want to switch basically.
It will automatically try to switch based on algorithm configured.
It will try, but it will first check if there's any running job at that host. And if not, it will then try. But if there's a running job, it will wait until the job is finished and it will switch to the management. Any other questions? Yeah.
So, is there any drawback to using shuffle
Drawback. So a drawback for shuffle. Basically, you are relying on a random list that's being generated for each host by the given list that you have. The drawback could be that if you're running a large number of hosts, you can end up with multiple hosts being connected to one point. It's a chance, you know. It's random. You have no guarantee that it will be fairly good balanced. All right. Thank you all.